Pretty sure Ben only signed up for this class for the toys.
Have we turned in number 23?
We have not yet.
Okay.
It will probably be next class.
Okay, so I should study that tonight.
Study 23?
Because I wasn't here on Friday. It's bad.
I would finish it. I don't know that you need to study it right now, but
Mr. Thompson,
And that was just review we did last time?
yeah.
was this due last time? ACTM?
I have not taken that up yet.
Oh.
I wanted to, but we ran out of time.
So I haven't missed any new content.
Friday's,
Wait, what did we miss?
Friday's stuff was an AB review.
That was just like PVA.
Yes.
Wait, what worksheets do we do? Or like any new handouts? on
It's
Friday?
all on the
It was
website.
PVA.
I'm not going to look at
It was
it.
like particle motion. So just like effort.
Lana says she apologizes for failing the quiz.
She should be.
She probably didn't though. Hopefully.
It was power rule, product rule, quotient rule, chain rule.
Oh, well, like chain rule's really hard, so I wouldn't blame her.
Camden, here.
On the things.
Okay. Wait, hold on. Yes. Took this, took this, took this, took this. Oh, I haven't taken this one yet. Okay, so do that.
Parametric equation. Is that new?
Yes, that's what we're doing.
Oh, cool. Like, is that VC?
Uh-huh. Olivia's gonna be late.
Yeah.
I was like, actually, like, I don't like to be behind on that.
Yeah.
Because then I just don't understand it.
All right, good afternoon, guys. Your handout this morning, or this afternoon, number 24, is on parametric equations, which I don't think most of you guys know what parametric equations are. But as I mentioned on Friday, I really wanted to do this on Friday, but there were so many people out for school business that I waited till today to start this. But just a reminder, the stuff that we have done thus far together this year, the BC stuff, are these random purple topics that are spread out in other units. So we have not started the BC specific units at all yet until today. So today's start will be the start of Unit 9. So this one will be quizzed and tested. But the reason why I'm really pointing that out to you before we start on the notes is that the next class or two will still be about parametric equations. So unlike the other stuff, this one is going to carry over a little bit more. You know, if you couldn't do partial fractions, it doesn't hurt you too much later besides those question types. If you can't do integration by parts, it doesn't carry over to other question types too much. But with this is kind of the basics of parametrics, and then we're going to do more with it. So this stuff is going to carry on and potentially domino a little bit. So for that reason, you need to give it your full attention. So first up, let's go ahead and read the top of this so we know what a parametric equation is. So far we've been looking at a graph of one equation with two variables, typically x and y. Now we're going to look at three variables that will represent a curve in the plane. In the rectangular equation, we are able to determine where the object is located at a point, x, y. But with the addition of a third variable, often t, we are able to determine when the object is at that point.
There were no sheets up there.
Oh, they might be in the basket. Look, what number is this? 24? 25?
24.
24. Look in the BC. No, that's graded paper. Sorry, I thought I left enough out. Should say parametric equations at the top. Okay. So now we're not just talking about x, y, a point, we're talking about x, y at a certain time. So that's the three variables. X, y, and t are the main ones. Third variable, t, is often time but not always. So if x is a function of t and y is a function of t, that's where you get your three variables, x, y, and t. And what we're going to do here at first is we are going to sketch what this looks like. So here is a parametric equation for x. This time it's saying x is always 2 times whatever the time is. So when time is -1, x is twice that. Double time to get the x values for this particular question. And then the y values will come from the y of t equation. So the y values are going to come from time squared minus 1. So what would this last one be? 3. You might want to draw a couple arrows there so you remember where those came from. But now I've got points, x's and y's, at a specific time. So let's go ahead and make a graph here. I think this is the only graph we'll do today. But plot -2, 0.
Isn't x -1 for t equals -1/2?
One more time.
Isn't x -1 for t equals -1/2?
Here? Yeah. Check. Okay, so -2, 0 is a point. -1, -3/4, 0, -1. Just plot all the points. Now, we don't know what's happening between these points, but we can guesstimate that it's probably a pretty simple curve that connects them all. Now, the only thing additional that sometimes people do with parametric equations is we show the direction of the graph. So, as time gets bigger, it's going this direction. And the way we show that is with those arrows. So as time increases, the points go from here to here. So add a couple arrows to your graph to signify the direction of the graph. Now, I almost forgot to say this with last class because it doesn't come up in any of the examples, and I don't know that you really need it per se, today at least. But your calculator can graph parametric equations. So I just want you to know to be aware of this, and you can play with it later on once we finish up with the notes. But sure, when you go to graph something, it wants y equals, which is not what we have. We have x equals and a y equals. But if you were to go to mode, like the 4th or 5th option down, function is for y equals. But if you go over and highlight parametric instead, now when you hit y equals, it asks for x in terms of t and y in terms of t. So you see how this is what we just graphed? And if well, it has window settings there. I'm not going to try to make it look just like that. But you see it's the same thing that we graphed. So anytime you want to graph a parametric equation, where it's asked for x equals and y equals, just go to mode and change it from function to parametric. You will need to do that sometimes. You just don't need to do it today, I don't believe. We also have to do some polar stuff in this unit, so that one right there might be useful at that point. Okay, so another thing we need to do is there's a process called eliminating the perimeter. So eliminating the perimeter is to try to come up with an equation that has no t's in it. So we are trying to rewrite the two parametric equations that have t's in it into one equation that does not have t's in it. And this is really just substitution. I can look at this and say that t is the same thing as x over 2 to solve it for t, and then substitute it in for y. So t squared minus 1. Actually, this wouldn't be y of t anymore, it'd be y of x. So y is x squared over 4 minus 1. So solve one of them for t, substitute it into the other one, and then you get an equivalent equation that doesn't have the t's in it. So if you wanted to graph both of these, or have your calculator graph both of these, that's fine. And then if you graph this regular equation, they should be the same thing. So just a different form. And again, this is called eliminating the perimeter. I have no idea why it's called that, but getting rid of t's out of the equation. So if we try to do the same thing here, this one's kind of an unusual thing, but you need to know this identity for later anyway. If x is 2 times cosine of t, you could divide both sides by 2. And does anybody know an algebraic way to get rid of cosine? Right, you could do arc cosine or inverse cosine on both sides. But in this case, that's going to make the question more complicated than we want it to be. So instead, what if I said, let's take this and square it. Or no, I'm sorry, not yet. If we take this Pythagorean identity that you're going to use again later in a few questions, and over here we could solve this for sine t. Sine t is y over 2. This is like y over 2 squared. Over here we could solve this for cosine t. Cosine t is x over 2, and then it's being squared. So we could say y squared over 4 plus x squared over 4 equals 1. That's fine. Or if you'd rather multiply everything by 4, it would be like that. Now, what does this equation look like if I graph this? Very good, it's a circle. And how big is where is it centered? Okay, whatever you're subtracting from x, comma, subtract whatever you're subtracting from y tells you the center. What is the radius of our circle? It is 2, correct? The square root of this. So, the reason why these often have x's and y's in them is, notice, if you're talking about an equation that's actually a circle, you need x's and y's, because if you want to know the slope or the derivative at 1, it could be up here something negative, or it could be down here something positive. So that's why you have to plug in an x and a y if you're talking about those. Okay, so parametric equation has x's, y's, and t's typically for time. Eliminate the perimeter just means rewrite it where it doesn't have t in it. So solve one for t, substitute it in for the other, and solve it. This one's kind of unusual because you have to start off with this, and there's no real hint how to do that. And then on the next page we can look at the actual calculus. So again, that's not really calculus. Parametric equations used to be taught in pre-calculus, but we don't do that much anymore. But of course we are going to want to know something like the derivative of this guy. So derivative dy over dx The way you're going to find dy over dx, so we can use derivative, is when I take the derivative of this would be dy what? dt, right? Because t is the variable. And if I take the derivative of this, it would be dx dt. And neither one of those match up with this. So you have to figure out how to use these. So this is kind of like a formula, but I'm going to show you why it works. If you take dy over dt, which is just taking the derivative of y with respect to t, and then you divide it by dx dt, because dividing by a fraction is the same as multiplying by the reciprocal. And when you do that here, you need to see that the dt's cancel, and you're left with dy over dx. So this is like the formula that we need to solve for dy dx today. dy over dt divided by dx over dt. Take the derivative of y with respect to t, take the derivative of x with respect to t, and then divide them. And I will tell you, when I redid this at the end of last week, my most common problem by far, even though I know this formula, is sometimes I get kind of careless and I would put this in the numerator and then that in the denominator. Just be careful with that, because again, that's my most common mistake. Okay, so question 4 is asking us to practice this. So dy over dx is going to come from dy over dt, which is 1/2 t, divided by dx over dt, here's y prime in terms of t, here's x prime in terms of t. And when you divide those, that's what's going to simplify to dy over dx. Okay, so 1/2 t divided by this is the same as multiplying by the reciprocal. So times 2 divided by 2 cancel, and what is t times square root of t? Three halves. Multiply things with the same base, you add the exponents. So that derivative would be t cubed. So the individual pieces, dy dt, just normal derivative rules, dx dt, normal derivative rules, but then you have to turn around and divide those, and divide them in the right order. Okay, let's do that again, and then I'll have you start to practice before we go over. So I would like the equation of the tangent line. So that is going to be, start off with point slope. Tangent lines are always linear. And I want to write it when t is pi over 2. So should I put pi over 2 in for y, y1, m, x, or x1? Very good. None of those. They're not the same things. Two totally different things. But how can I find the x value of the point that I want?
Plug in.
Plug in what? Into what?
X of t.
Right. This x of t is telling you the x value of the points, just like the table on the front page. So x at pi over 2 would be e to the 2 times pi over 2, which would be e to the pi. When the time is pi over 2, x is e to the pi. Okay, somebody else, how am I going to find the y value of the point?
Plug in pi over 2 into y of t.
Right? So y of pi over 2 is cosine of pi over 2, which is 0. So if you want points, just like you did in AB, you plug that into the functions. The function of x, the function of y. But if you want to know slope, you need derivative. So we're going to have to think about what dy dx is. So to find dy dx, you need to do dy dt divided by dx dt. And that's kind of a messy derivative, but I really only care about the derivative at this one instant, when time is pi over 2. So if I plug pi over 2 into this, the numerator becomes -1. The denominator becomes 2e to the pi. So the slope is -1 over 2e to the pi. I feel like I'm saying eat pie when I say that, but e to the pi. And subtracting 0 doesn't do anything, so I probably wouldn't leave it in my answer. Okay, so point comes from the functions, slope comes from the derivative. For us, derivative dy dx comes from dy dt divided by dx dt. Are you guys okay where the negative sine t came from and the 2e to the t came from? Yes? Okay. All right, finish copying that one down, and then I would like you to try question 1. It says eliminate the perimeter. So if you need to scan the other page to remember what that means, that's fine, but take a minute or two to try that, and then we'll go over it to make sure you're on the right track here. We'll do the first 4 or 5. Actually, we'll just do the first 6 as guided practice. 6 gave me a lot of problems, so it might make sense for y'all to see too. But right now, just try 1, see what you get. I'll even go one step further, and I will share my answer, so if you can get to that, you can keep going and not listen to me go over it in a minute. Okay. If you are still stuck with question 1, go ahead and follow along with me. So again, eliminate perimeter just basically means come up with an equation that is equivalent to both of those without the t's in there. So you need to decide to either solve this for t equals and then plug it into this, or solve this for t equals and plug it into that. Either one should be fine. One of them's probably going to be easier than the other. I chose to go with this one, and I switched these two things around because when I look at this is exponential form. Bless you. And solving for exponential form, you probably want to switch it to logarithmic form. So what does this look like in logarithmic form? Okay, so you just swap these two around, put log out front. So the natural log of x is equal to negative t, therefore t is equal to the negative natural log of x. You guys okay with that? If you didn't see it? Okay, and then now that I know how big t is, I can go up here and plug it in place, substitute it in place of t. It's just like solving a system of equations, really. So instead of saying t, I want to put negative natural log of x. Because this negative 2 is being multiplied by a logarithm, you can bring that negative 2 up front. Or I'm sorry, up as an exponent. You're welcome to move it back and forth, however it makes sense. And what is e to the log base e of this stuff? Right. Some number to the log base of the same number of some stuff just becomes that stuff. It's one of those random log properties that you don't use very much. And then that's why that comes out to be that. So that one's a little bit harder on the algebra side, but make sure you understand the process. I solved one of them for t and then plugged it into the other one. It gave me the same equation, but without t's in it. Okay, make corrections there if you need to. Write yourself a note for later if you need to, and then try question 2, please. And I have my answer up for number 2. So if you get that for number 2, you can keep going. All right. If you need help with this one, I'm about to go over it. So if you didn't figure out how to get this for number 2, first thing is you need to read through there and figure out what they want. So slope of the tangent line is the same thing as derivative. The derivative at that value gives you the slope of the tangent line. So just a different way to ask for that. And the way you're going to get the derivative dy over dx is by taking dy dt divided by dx dt. That's it. Same formula we put on the top of the page. So. Okay, everybody okay with 2? Okay, so again, I said I'd stick with you through 6 before I let you work at your own pace. So try number 3. Answers on the board. If you think you did it correctly, make sure that's right. If it's not, try to find your mistake before we go over it. Okay, if you still don't have this for number 3, okay, I'd ask you to find dy dx and then make sure it's a function of x. So dy dx is going to come from doing dy dt divided by dx dt, and then of course we can reduce this a little bit. This is the same as 1/3 t. Now how am I supposed to know what t is?
Solve for t using this equation.
Okay, so basically the eliminate perimeter, like they've been talking about on other questions. You could solve this guy for t, and then here's the derivative, but here's the derivative in terms of x's. If t is equal to this stuff, I can just plug that in place of t. So again, it's important that you understand where this is coming from. This is one of their easier, if you want to call it a formula, really you should be able to figure it up, I guess, but that's, you're not going to want to do that every single time. So dy over dt in red over dx dt in purple. That gives you the derivative. And then if you need in terms of x, replace the t stuff with x stuff. Okay, anything else about number 3? Okay. Did anybody finish number 4 yet?
I don't know if we got it right.
Did you get that x prime is what?
What do you mean x prime?
Well, once dx dt, same thing. What'd you get for dx dt?
Well, -3.
That is correct. So if you got -3, keep going. If not, then I'll go over it in a few minutes, but I want to make sure everyone's had time to try it. You need to try it to make sure that you aren't making some other mistake. Okay, so if you struggled with number 4, I have a very good idea of what might have happened here. So first off, you needed to take the derivative of this mess. So x times y, you have no option but to do product rule. So you're going to do the derivative of x with y left alone plus x left alone, derivative of y, equals, or not equals, plus, and then take the derivative of y, equals the derivative of 9, which would be 0. So what I suspect a lot of you made a mistake on right here is not calling this x prime. You might have called this 1. Because most of the time, you take the derivative of x with y left alone, you're going to get 1 times y. Why is this not a 1 and instead it's an x prime? X is a variable, but normally when we do derivatives, we do them with respect to x. But these we're doing with respect to time. X is not the same thing as t, so you need an x prime. Y is not the same thing as t, so you need a y prime. Y is not the same thing as t, so you need a y prime. They didn't have matching variables. So just like when you did implicit, every time you took the derivative of y, you needed a y prime, because taking the derivative of y with respect to x, y and x are not the same thing. Well, x and y are not the same thing as t. So every time you take the derivative of x, you need an x prime. Every time you take the derivative of y, you need a y prime. The only time you don't need something prime is if you were taking the derivative of t. Okay, so I did that, and then x prime is what you're solving for. So I knew I wasn't going to get that. I don't know y yet. I know x is supposed to be 2. I know y prime is 3. So before we have an algebraic equation to solve for, I need to know what is y supposed to be. Well, you know what x is, and you've got an equation to plug that into. So when x is 2, y must be 3. So you end up with 3 times your answer should be equal to -9. So your answer should be -3. Again, I suspect that more than half the mistakes are right there at the beginning. You need to be conscientious about taking the derivative. If it's with respect to t, the derivative of x gets an x prime, the derivative of y gets a y prime. Okay, if you have a question from that one, go ahead and let me know. If not, go ahead and make any mistakes or correct any mistakes you need to. And then keep going to 5, please. Did anybody get this for number 5? I feel like it might have been a plus instead of a minus.
I think it's a plus.
Wait,
Because when you plug in pi, then
wait, not
Why?
minus pi squared.
yes.
Minus pi squared?
Or pi x minus pi squared.
Not plus
Yeah,
pi.
wait, I got minus
Because
pi.
it would just
Wait,
be,
hold on.
I got negative pi x minus pi squared.
sure, it would be pi times negative 1.
Alright, sounds like we got lots of different answers there. Okay, so this question,
X minus negative pi.
okay, y'all are gonna miss the part that you missed if you're not paying attention here. I'm not gonna go back over it. So, equation of tangent line. Tangent lines are always linear. Start off with point slope. Okay, t is not the same thing as y, y prime, or y1, m, x, or x1. So don't plug pi into any of this stuff yet. But to get the point, you need to plug the time into x. So that would be pi times cosine of pi. What's pi times the cosine of pi? Okay, negative pi, so that becomes a plus pi there. If we plug this into y, pi times the sine of pi would be what? Okay, 0. So that goes in place of y. The slope is going to come from the derivative, so we've got to calculate derivative. So dy dt, you have to do product rule on. The derivative of t with sine t left alone plus t left alone times the derivative of sine t. Now notice I'm taking the derivative of t stuff with respect to t. That's why I don't have a bunch of t primes like I did x's and y primes in the last question. The same thing with x. dx dt, got to do product rule. The derivative of t is 1 times cosine left alone plus t left alone times the derivative of cosine, which would be negative sine. This is how you find dy dx. You really, really, really need to write this on your paper. It's important for you to realize what this is. Okay, and then if we care about the derivative when t is pi, we can plug pi into all of this mess. And what is the sine of pi? Okay, plus pi times the cosine of pi, which is, okay, divided by the cosine of pi, which is still -1, minus pi times the sine of pi, which is still 0. So it looks like the derivative is negative pi over -1, or pi. The slope at that time was pi. And so your equation, subtracting 0 doesn't do anything. If you want to distribute the pi, it would be pi x plus pi squared. Those of you that said minus there, I think you maybe didn't do this unit circle right. Cosine of pi is -1, minus a -1 becomes a plus. Okay. Did that correct all the mistakes? Okay. Let's do one more on the board, only because number 6 is the one that gave me the most issue, and it's kind of embarrassing. But I'll tell you what I did, and then y'all can hopefully learn from my mistake. So it says calculator active, so you're welcome to use a calculator to help you solve at the end. But at the ultimately, when it says for what times t does the slope of the line tangent, so slope of the line tangent, what's another name for all of that? Derivative. So we really want the derivative. When does the derivative equal 1.5? So, because this is a weird number, this is where you need a calculator to solve. But to find the derivative, here's what I did. I did dy over dt. So I took the derivative of y divided by the derivative of x, bless you, and tried to figure out where that equals 1.5. Yeah, so what was my, and then I wasted 20 minutes trying to find my mistake.
Yeah, already.
Right, this was already dx dt, this was already dy dt. So I was just in the habit out of the last few questions. dy dt over dx dt. They were already given to you. You didn't need to do the derivative again. Okay, let me share this one more answer with you on the board, and then I would like you to use the solutions online to check. This one, with the help of your calculator, you should get about 0.644. So I suspect, like my first period, you guys might not quite finish this up, but go ahead and keep working, and then near the end of class I'll take a look around and see how far y'all got, and then find a reasonable spot to be at for Wednesday.
Do you mind if I charge my calculator here until
Yeah, you're always welcome to.
And it says, what's the time or how three syllables, 1.5, and so we just do
Oh, okay, now that makes sense. Shoot, I have to do that.
Okay, coming around to offer some individual help here, so if you've got something I can help with, just call me over as I come by.
So I just did it.
Are they
And then
useful?
set that.
In case you want to know, like, how the direction of something. It's a function that you know the direction of it. Like, how it moves over time. Not necessarily. It could be going from right to left. It represents It could be.
What you got?
Right here. Huh? Well, nothing. It represents that. I mean, so like, say we do it, right? Without parametrics, you could tell me using the derivative, you could tell me the slope at any given time if you plug X in the line. But what if I want to know the slope at a certain time and not necessarily a certain location?
Does that make sense? Or you can
So
do
like,
it
if you know a
like
particle
math.
moves
You don't have to
around a
skip
certain
it. So just say
you should
1
know
over,
where
did you
he
understand
is
like 1
at
over 2
3
t
seconds in terms of X and Y. You don't know where he's at.
So set that equal to 1.5. So just do normal.
So
If you want to use a calculator, you can.
The
So
time.
you can use, so in y equals that equation, 1 over 2 t. You would equal to
This is just kind of
or you can just do it by hand.
the introduction.
Whatever.
Again, the solutions are on the website, so please check your answers. I'd rather you check your answers as you work so you don't have to redo a bunch, but I'll leave that up to you.
It's just, you don't.
it's just a lot of survivors, like the bread and butter, so
Hmm?
survivors making those, yeah, and then bread and butter. So why don't you just do butter?
Right, you can do it, it just takes.
Local A&W, so.
The first one was 0 because the derivative of 2 is 0.
Oh, yeah, so just multiply it.
Okay, is anybody still stuck on number 7? Okay.
Yeah.
Oh, yeah. Wait, there's a 1 over 2 or 0? Where's this? Oh. Yeah, give it.
For president, are you ready? No? Are you ready? You should run for everything, Patrick. Get elected to everything. You got a good enough reputation. Don't Patrick, everyone knows that you're one of the smartest people. You know that? So we're gonna get to seniors next year.
I got 32 and 3.
Audition team? I decided to go over for AMC. Band is already taking so much of my time. That's why Patrick's quitting this year. Patrick, what place do you think we'll get when you do?
Yeah.
think it's fine with soda. For sure.
It's actually bad. Because we're not gonna get back into it.
Wait, what is it?
Next retreat is at 11 p.m.
Wait, is it an overnight?
No, it's not.
No, it's another day.
So we can get back to the first
Wait, what time do you get out? So what time do we leave?
Yeah.
Leave after this?
I got in. What's your? Nice man.
8 a.m.?
Yeah.
We'll have our first
I'm gonna check the schedule. Oh, I actually felt terrible for missing this morning.
Why?
Because everyone, like, so many people skip, so they're probably gonna get, like, a speech.
Yep.
And talk about how we need to be, how we
It's
need to
collected
be.
punishment. No one's terrible.
Yeah,
I'm gonna get in trouble.
No, pretty much.
If it's just me, then I
Oh,
feel bad.
if you miss,
You give it to me, Anthony. We
Right.
all skip.
No, but it's like half, they said half the
maybe
time.
on your third one.
Oh my god.
No, I mean, that's what
Because I'm actually gonna, because I really probably would make leadership next year.
Talking about NHS?
Yeah.
What is the next year?
Next Thursday. Are you in that?
You're sick?
Yeah.
And then,
You applied junior?
didn't you mean everyone's sick? You just like it all.
I mean, you must be so
Semester.
Yeah, we're gonna blame it all on Denny.
The essay was stupid.
You just had to get it. You just had to write it. You didn't have to be good. You just had to write it. Like the last page of your own. Yeah, and you have to use those words. You have to use three of the words they give you.
It wasn't as bad as last year. Or apparently for my sister, it was like, everybody was
Oh, that's tough.
that'd be even worse, I think.
Oh, that's when they had
You just have to meet the page requirements and they're gonna
Yeah,
go.
we're in the news. He was basically getting a
I kinda don't wanna do it. I mean, the only thing I'm not gonna have
It's
if I'm
15 the whole year, I think. So
yeah, but there's an
7.5
hour requirement by the end of the semester.
7.5, I think.
That's not very
No, it really isn't that bad.
There, I heard there's like a tutor.
Yeah.
And then everyone's trying to make stories.
Is it 5 hours? Sponsored?
I can't remember. You get to get more sponsors than you.
I thought it was 5 semesters.
I'm pretty sure if you get more non-sponsored, I think it goes
Yeah, that's your
No, where if you get extra sponsors.
We're not gonna be, I think Derek's gonna be.
I think I already really goes that.
When did you get in? I forgot it today. When did you get in?
No, he applied this junior year.
Oh, so you were.
I already got 3 sponsors.
But when he goes to high school, what's he gonna take?
For the McNair thing. I just gotta, I don't know the whole process to put in the hours.
We just got in today. Rich was in my class.
Nice.
I thought it was, I thought like the senior, like, it was like the middle of December.
Wait, so he's gonna take it?
Yeah,
Like the,
but they just like got back to us.
oh,
So like,
Because they had to review our application, make sure we like his GPA and.
yeah.
he's already taking ACAS out.
Are you required to be on this session?
You already finished all the classes. Wait, they can take the UA, they can take like the UR classes like that. They can have the same classes at universities, like your application, it'd be really funny. Dude, imagine being a grad student and being in the same class as a ninth grader. It's crazy. You're such a good student.
You went to Dallas already.
I hurt my back.
Appreciate it.
I got my back off.
and then just message.
Get a water heater, water heaters and a fritz, so I can turn on. I could not do that with 5 hours.
I take night showers.
No, like a water heater. I don't even know if I'll do it tonight. Yeah, it's just so cold, I don't want to do it.
Just have to take a little
I
nap.
can't be practicing every single one once else I'll forget.
This has never happened before, though.
Literally practice more throughout the entire week.
Over there.
Yes, we do have to hang out outside school. No, we have to study, that's what we need to do outside of school to pick out. This is the only time.
Oh, yeah.
Mr. Thompson.
Over here 5 minutes before I said.
Can you change the seating chart, please?
Oh, yeah, you're gonna be out in the hallway. I'll put you in the math closet across the hall and,
Is it math closet?
yeah. That's where we store math supplies and stuff. That's the Miss Penner's room. You ever see me go over there for anything?
Mr. Thompson, are you gonna write good things on my college app next year?
It's what values of students.
Not at this rate. You guys aren't gonna be far enough along for me to ask the questions I wanna ask.
Yes! I did get it right, okay. I'm not very good at this.
You're not going to? No, I'm going to, but
Or am I very good at math or calculus? So I'm just, it's a small victory.
Didn't you say you got a 4 on the AP exam?
Yeah.
That's pretty good.
I thought I failed. I'm being honest. I thought I got a 2.
Well, you
I got a
probably
4 and I was like, oh.
you probably failed in the sense that you got less than 60%, but you probably got less than 60% of the points, which normally means you would fail. But on the AP exam, you don't need 60% to pass.
I mean, most of it was easy. It was just the FRQ section.
Yeah, the FRQs are killer.
Like, I love one of them. Like, it was just like, I couldn't, it just didn't come in line. The other ones were easy though.
They have like 4 parts.
Huh?
no, it's okay, Liam.
Yeah. That's a lot of
And I thought I would fail. I had to lose my mentality.
No, I'm saying just because you part A maybe didn't come to mind, but what about part B, part C, part D? Totally different questions.
Yeah. But I put most of my time in.
be like particularly bad this time. It's better to write something great.
Yeah, I know. I was stressing. It wasn't a good test.
I would be happy with a 4 personally.
Yeah,
And if you're not, you get a chance to get a 5 on it this year.
I'm happy with the 4. I'm totally happy I passed. I'm just, I'd like to just be good in general. So we can get like, I don't know.
4 is pretty good.
I know, but I'm really bad when it comes to being in class. Well, not really bad. I'm just not as good as I want to be.
You just need to focus yourself studies.
I have been focusing. I'm just.
Oh, didn't we have like an entire like conversation about anime?
That was last time. This time I'm actually focusing. Like what? Like, but
What
if
are
I
you
like,
right now?
I was part of that.
well, I was focusing until you guys started talking to me. So like,
You're gonna blame us?
I'll win.
I mean, I can't be talking either.
Yes, it is.
I mean, like when I actually apply myself to doing the work, I just wish I was slightly better at it.
Diego, did you gotta practice this morning?
I barely, like I. They should have been glad that I was there.
I skipped.
I wanted to.
I figured everyone skipped.
Oh yeah. It felt like a clip show. We were going from thing to thing. It was just like, what the heck? Yeah. It's like they expect us by next Saturday to have part 3 really good. I'm just thinking they should like cut their losses and then not do it. Still practice it, but not do it at Union because that's gonna drop us points.
Part 3?
Yeah.
No, I feel like part 3 is gonna go. Wait, we're already getting distracted.
Battery sucks though because we don't know it. I don't like it.
Okay, we are down to about 10 minutes here, so let me tell you where I want you to be by next class. I would like you to finish through question 12. So if you made it past that, you don't have any homework. If you did not make it to question 12 by the end of class, then I need you to go through question 12 for homework, check your answers, and make sure that you feel comfortable about those first 12. If you think you need some extra help and we're running out of class time, you can sign up to come see me during advisory tomorrow or Wednesday if you think you need some extra help. But you guys know you have to sign up for those things on Monday. Okay. Well, they already did it. You were absent, so you get 2 days. You should have it done by Wednesday. Number of days you missed plus 1.
Wait, so we get 3 days.
Number of days you missed plus 1.
Dude, we have 2 days to finish this.
So you should be made up by Wednesday.
Okay.
That's fine. It's DBA.
Yeah. If you watch the class recording, we went over the first 3 pages.
Hold on, it's 5 pages though.
No, it's not. It's 4.
Yes, it is. It's 1, 2, 3.
I'll try to do it tonight because I most definitely can't do it after rehearsal.
Okay, this is important, please. First, I need to know which one y'all think on the meme for the day.
I would think number 2.
Doesn't make any sense. I think number 1, because you base it around how the legs are hitting the ground.
Me personally.
Except for on dogs for some reason, but that's dumb.
Yeah, but if you put shorts on your dog, it'd be more like the second one, not the first one.
Yeah, but it shouldn't be. It shouldn't be.
I don't know.
Because it should be based on
Okay,
like
it's easier to put it
what's
on
going
like
on
the
the
second one
ground.
though. It'd be really hard for the first one.
Yeah, it would. But it would be more correct to do the first one.
I would be more correct.
How do you wear your pants?
2 legs.
2 legs.
How do you wear your
But-
pants?
But it's based on what are legs, right?
Oh my
On a
god. Why are we
four
getting theorized?
on a 4-legged thing, you would need 4 pant legs.
Guys, why are we getting
Which
theorized?
would mean it would be the first option. Like if you made an elephant wear pants, it would have the.
I think
4
y'all should
legs.
get this to Mr. Reef as a physics question and see what he says.
What would Mr. Reeves say? That's a better question.
Okay, and then today's puzzle. Now, on today's puzzle, if you think you've got the answer right, if you want to show it to me in your calculator, because the answer is a number, I will confirm or deny it. But I don't want you to say it out loud if you figure it out.
On the puzzle?
That's the puzzle.
Oh, okay, cool.
Okay.
Oh,
If you think you know the answer, just type in your calculator and I'll look at it and tell you if you're right or not.
I wrote it on the corner of my computer.
can I just whisper it to you?
Mr. Townsend. Mr.
No
Townsend.
whisper.
Nope.
No?
It's embarrassing. I don't know. I thought you wrote it down.
You know what number it is. It's a perception problem.
No, I'm looking upside down.
It's always Thursday.
Oh, I guess if you're
What's French for
Nobody else? I've only got one right answer so far.
BLEU, I think. BLEU.
I'm making a. I'm TA.
Wait. You don't quote me on that.
I know. I'm going to Google Translate, but it's okay because it doesn't have to be real. I'm just using. I'm making a book for my German 1 kids. Because
This one's, somebody got this one in like 5 seconds, guys.
I have it.
Oh, well, if you've seen it, then that's not fair. No, put it on paper. You are incapable of whispering anyway.
Can I? Let me just.
Correct.
Okay.
Wait, don't tell me.
That's the first time I've ever heard you whisper.
Well, because I don't usually have to whisper.
Always. You know your audience. If I'm talking to Leo, I don't talk at this volume because he can't hear me. If I'm talking to you, I talk at this volume because it's enough for you to hear me.
Some people just naturally have like louder voices though. It's
No.
not something we can control.
No, that's not a thing.
Yes, it is.
Sometimes y'all are louder than other times. Okay, if you didn't figure it out, here's how to go about it. What is this parking spot number?
91.
Oh.
Yeah.
I see.
Not 16.
I get it.
What is this?
90, 89, 88, 87, 86.
You're looking at the numbers upside down. Your perspective is backwards.
it's a perspective issue.
It's right there in front of you the whole time. I like that one. That was a good one. I like that it's not easy for some people to see.
I should find a good math riddle.
I wish I would find good puzzles for me.
See it? Yes. Let's go. Another right one. Yeah.
What is that, 2 in a row?
Yeah. It's the little victories.
Okay, y'all got about 3 minutes, so you need to finish up your thought.